Okay, in this video we're going to prove that cos square theta plus sine square theta equals 1. In the trigonometry section we have to derive 8 formulas. Okay, so this is one of them. We have to prove where this formula comes from. So to do this, I'm going to be using Pythagoras' theorem. The first thing you'll do when you're shown this or proving this is you will draw the unit circle. Okay, so there's my unit circle. Okay, and I will put in my x-axis, I'll put in my y-axis. Right, and now I'm going to draw, I suppose, a line of maybe whatever many degrees, and I'll call that theta. Okay, and I'm going to bring a line then straight down. So what I'm doing really is I'm drawing a right angle triangle in the unit circle. Okay, so now let's start labeling the sides. Well, the length of this is going to be 1, the hypotenuse. The reason for that is it's the unit circle, okay, so the radius has to be 1. And down here, okay, so in relation to this angle, this is going to be the adjacent side, but we're not going to look at it that way. We're going to call it cos of theta, okay, because we would know that. And over here then is sine of theta. Okay, we could call that the opposite side, but in this method we're calling cos of theta and sine of theta. Okay, so I want to prove that cos square theta plus sine square theta equals 1. To do that, I'm going to take Pythagoras' theorem. Pythagoras' theorem says that a squared plus o squared equals h squared. Right. Well, our opposite is sine theta, our adjacent is cos theta. So cos theta squared plus sine theta squared equals the hypotenuse, and the hypotenuse is 1 squared. And cos theta squared can be written as cos squared theta. Sine theta squared can be written as sine squared theta. And that equals, and 1 squared is 1. So there we go. That's the easiest of all the formulas to derive. Okay, so quick recap. Draw your unit circle. Draw a right angle triangle in that circle. Label them cos theta, sine theta, and 1, and use Pythagoras' theorem to show that. Okay. Right, now we're going to prove sine rule, or derive sine rule. Okay, and sine rule is a over sine a equals b over sine b plus c over sine c. To prove this, we're going to draw a triangle. And I'm going to label the angles A, B, and C. And the side across from A is small a, the side across from B is small b, and the side across from C is small c. Okay. And we're going to use the half AB sine C formula. Okay. So we're going to use this half AB sine C. Okay, so this half AB sine C formula, if you remember, that is to get the area of a triangle. Okay, well, let's go. So the first one we'll do is a half AB sine C. Well, that's, if we take AB, so it's this and this, and the sine of this. Okay. That's going to equal, if we take, okay, we'll just try to fix that. Okay, let's say we take this angle and these two sides. Well, that's the same thing, isn't it, really? Okay, that'll still give me the area. So in this I'm going to say half AC sine B. And that will equal, and you should be after seeing it by now, if I take this angle and these two sides, that will also give me the area. So that will equal half CB sine A. Okay, now I'm going to multiply across by 2 to get rid of the half. So if I multiply by 2 the whole way across, I'll get AB sine C equals AC sine B equals CB sine A. I really should have that as a capital A because it's right. Now I'm going to divide by A, B, C the whole way across. Okay, so watch this. This is the kind of magic. If I divide this by AC, well, the A and the B will cancel each other out, so I'll just be dividing by C. And if I divide this here, this AC sine B by ABC, the A and the C will cancel each other out and I'll be dividing by B. And if I divide this by ABC, the C and the B will cancel each other out and I'll just divide by A. So what I'll be left with is sine C over C equals sine B over B, small b, equals sine A over A. And I can't flip them all upside down. Sorry. Okay. And well, actually we may as well just get the A's first. So A over sine A equals B over sine B equals C over sine C. Okay, so I'm after proving it there. And just see the way I flipped this to here, I flipped them upside down. If that's not sitting right, well, just watch this. Let's prove I can do that. So 2 over 4 equals a half. If I flip this upside down, I get 4 over 2. If I flip this upside down, I get 2 over 1. And 4 over 2 is 2, and 2 over 1 is also 2. So if they equal each other here, if I flip the both of them upside down, they'd also equal each other here. Okay. Right, okay, that's that. Thank you.